So maybe I'll ask not only one, I'll ask I think a few of you who are here to see what you understood from yesterday's uh, session. So maybe I'll first go to Janil.
Yes, sir. Am I audible?
Yes, you are audible.
Sir, yesterday's session was interesting on trigonometry. We did various problems to calculate. First, a problem was like we have to calculate when a ship will reach a shore.
Mhm.
It reaches from point A to B in 1 hour.
Okay.
And also, sir explained us why the triangle is a fundamental shape.
Hmm. Okay. Manan, how did do you see what you did yesterday?
Yeah, yesterday we basically just talked about really basic concepts about triangles, like calculating distances between two places and stuff.
Yeah. Okay. Fine. So now uh, you know why you study trigonometry and why it's called trigonometry. Do you know? Can anyone uh, say anything about it?
Sir, I think it is triangle geometry. Try for triangle and
And
sir, I think it means triangle geometry.
it's actually just a measurement of triangle. Okay, so that has got a special uh, the full subject kind of thing in a part of mathematics. It's not full subject, I should say. It's part of mathematics, and it is used in so many places in within mathematics because once you know a triangle, it can be used in a large number of places. Where once you understand that it's similar to what we already know, it's very easy to take it from there and solve it as a triangular problem. Means yesterday already saw a few applications of it, right? So today I'm going to introduce some uh, more formulas first, okay, and then we'll jump into some of the problems that we may be getting in this area. Okay, so let me. Uh, so we have Srihari is here. Okay, maybe Srihari, can you also summarize what we did yesterday before we move ahead?
Yes, sir. So yesterday we had this beginning session for trigonometry with some basic concepts like why triangle is a fundamental shape, and we also had some quite interesting questions given by sir. Questions about ships, some questions about how to calculate the size of a building, etc. So on and so forth.
Okay, fine. So mm, I think you've got a good idea on how we why do we need trigonometry and where do we use it, right? So let me now share my screen, and I'm going to go over some of the little mathematical things now. So you, from the understanding point of view, I think you're all clear, right? What I assume that why do we need trigonometry? maybe I would ask you to switch on your mic so that we can talk more interactively. Okay. Unless there are more than one people together, when the mic starts echoing, I'll ask them to then keep yourself on mute. Otherwise, I think it's better to keep your mics on. Okay. So yesterday you knew about sine, cos, and tan, right? Did
Yes,
you
sir. They are ratios.
the ratio? So you understand what are they?
Sorry, sir. Could you repeat?
I am saying that you already know what is sine theta, what is cos theta, what is tan
Yes, sir.
theta.
Yes, sir.
Okay. So going from just theta, I am now going towards summation of two angles, taking a sine or cosine on those. Okay. And here those. So if we have an angle A plus B and we take the sine of A plus B, it can be found if we know the sine of A, sine of B, and cos of A and cos of B. Okay. So for example, if someone asks you about sine 15 degrees, how do you write degrees? Insert special character. Okay. So can someone help me find this? Srihari, I think you are the senior most here. Do you know what is value of sine 15 degrees?
Sir, no, sir.
No?
Sir, is it um, 1 by root 3?
No, it's not, I think, as simple. We'll have to kind of, I think you all know about the values of sine, cos, and tan for angles 0, 30, 45, 60, and 90,
Yes, sir.
right? So all these are easy ones we need to remember, and we can easily remember actually, right? But other angles like 15 degrees or 75 degrees are not so easy to remember. Okay. So if you want to compute some time, how do you compute? Any idea? No? Okay. So let's the first kind of problems which you may need to uh, may encounter in books is finding angles or finding the ratios for such angles like 15 or maybe 75 as well sometimes. Okay. So let's see how we can compute them. We can use any of these formulas. So that's the hint now. Can anyone now uh, suggest a way to compute sine of 15 degrees? I'll give you a few minutes to think. Now you have the formulas with you. So uh, all the formulas, anyone you want to use, you can use.
Yes, right. I got away, sir.
You got away. Okay, very good. Try to do it. Srihari, how about you? You got something? Shaurya? Manan? Hello.
Yes,
Sir,
sir.
you are audible.
Yes, sir.
Yeah.
You're audible, sir.
Okay, so please try it, and then we'll get back in a minute.
I
Yes.
got it.
Sir, I've got an answer, sir.
Okay, you got an answer. Very good.
Yes.
Anyone else got some answer?
I got it.
So that was Manan.
Yes.
Okay, good. Janil,
Sir, I also got.
you got. Okay, Sharia.
No? Am I audible?
Yes, you're audible.
Yes, I also got it.
Okay, so today Sharia will kind of help me derive it. How did he solve this problem? So we need to find value of sine 15 degrees. Okay.
So I
Yeah.
used the formula which we had of sine A minus B.
Okay. What was the formula?
The formula was sine A into cos A.
Sine A into cos A, sine A into cos B.
Oh, okay.
Okay.
Cos B minus sine B into cos A.
Into cos A. Okay.
So
So
now we
what
can take A as 45 degrees and B as 30 degrees.
here 30 degrees. Very good. So what it becomes sine 15 degrees
Yes.
equal to how much? Sine
It's equal to
45 degrees
45
into
degrees into
cos
cos
30 degrees
30 degrees
minus
minus sine 30
sine
degrees
30 degrees
into
into
cos
cos
30.
30 degrees.
Yes.
And what is its value?
Sine 30 is half
Sine 45 is how much?
1 by root 2.
1 by square root of 2. Let me just type it in this way. Into cos 30 is how much?
Cos 30 is root 3 by 2.
Square root of 3 by 2 minus how much is sine 30?
1 by 2.
1 by 2 into cos 45,
1 by root 2.
1 by square root of 2. Everyone got the same thing, right? Means this 1 upon square root of 2, I think, is common from both the sides, right?
Yes.
So 1 upon square root of 2. And inside what we have is square root of 3 upon 2 minus 1 by 2.
Yes.
Okay. So that becomes square root of 3 minus 1 in the numerator, and denominator you get 2 into square root of 2. Is it right? That's what everyone got?
Yes, sir.
Yes, sir.
Yes.
Okay. Anyone did it differently?
No.
Sir, we could have done maybe with some other identity.
Okay, what is the identity?
No, sir. No. We could have done sine A plus B, but no, we could not.
Okay.
I think this might be the only one.
Okay, what if I ask for 75 degrees? What will you do?
Sir, we could use sir we could uh, we could use 90 minus 15
Okay. Anyone else has got any thoughts? 90 minus 15 के अलावा?
or 60 plus 15 also could be done.
Okay, 60 plus 15. Okay, what else?
45 plus 30.
45 plus 30, very good. Which one is going to be easier? 45 plus 30 or 90 minus 15 or 60 plus 15?
Sir, I think 45 plus 30 because it's got
Both
easier numbers.
both values are already known to us, right?
Yes.
Okay. So I think yesterday you might have also run some other formulas like sine square theta plus cos square theta is equal to 1. You tried? Sine square, how do I write square? Insert this format. Text, yes. Superscript is control dot. Sine square A plus cos square is equal to how much? 1. Did you solve this yesterday?
Sir?
Did anyone solve this yesterday? You read this yesterday, right?
No, sir.
No? I thought you were doing this. No one? Janil, did you solve this yesterday?
Sir, could you repeat? My network was gone.
I'm saying yesterday you might have done some identities. So
Yes, sir, I've seen this identity sine square plus cos square.
why you call it identity? Can anyone say that? Remember what is an identity?
Sir, I think it's a formula which is true for all values, for any value.
Yes. So you put any value of a, and this is going to be true. That's an identity. That's correct. So now you have. There was one more, I think. Can anyone help me recall? What was the other one?
Sir, I think it was tan is equal to sine upon cos.
No, that is anyways. So tan equal to sine a upon cos a. That's anyways there. But something in this kind of thing, square sine square theta plus cos theta involving
Sir, tan square minus secant square is equal to 1.
tan square or secant square. Which one is minus sign?
Sir, tan, um, So the secant square A minus tan square A is equal to 1.
Yes. Uh, can you help me in proving this? Someone? One wants to volunteer? This is always true, but I'm still not putting it in this category. This is one of the more basic ones. So, Janil,
Yes,
can
sir.
you help me prove this one? How will you do that if I ask you to do?
Um, Sir, I am not sure. What I did was I tried putting some values for tan and sec. Uh, Sir, maybe no, sir. I am not sure.
Okay. How about Manan? You know about it?
Yes.
Okay. How about Shriyari? Can you do that?
I could.
Sure, sir. I could probably help you with this.
Uh, can you repeat that? What you said?
So I can, you want me to prove this? That secant square A minus tan square is
Yes,
equal to
I'm asking. Will you be able to do it?
Yes, sir.
Okay, great. Shaurya, if I ask you to prove this identity, can you do it?
Probably yes.
Okay, great. So now, Janil, are you getting some idea on how uh, others are able to think they can do it? Do you have any more ideas now?
Sir, maybe sec square is equal to 1 upon cosine square.
What about cosine? What was the definition of sec theta?
Yes, yes, yes. It is hypotenuse upon adjacent. And similarly for tan is what is it? Opposite upon adjacent.
Okay, so
And then we can try to solve. Yes.
and
So it will be hypotenuse minus opposite upon adjacent.
so if I just write it by h and a and this o by a, I hope that will leave it clear enough, right?
Yes, sir. Mm, yes.
So when we do a square, what will it will become? H square, right?
Yes, sir.
So
Sir, and yes, from the Pythagoras theorem, we get h square is equal to a square plus o square. We take o square to the other side, we get h square minus o square is equal to a square. And
so,
we can replace the value here, so we will get
so h square minus o square will be in the numerator, and denominator will be how much? A square,
yes,
right? What is
yes,
h square minus o square?
a square. So a
That's
square
a
upon
square.
a square is equal to 1.
Okay, so clear to everyone? Why we don't need any particular value to prove this. Just use Pythagoras theorem, and you should be able to get it by the definition, right?
Yes,
Okay,
sir.
great. So now I'm going to give you another kind of problem which you may need to be solving, and that is when you know any one of these angles. So let's say if you know sine of A in a given triangle is 5 upon 12, you know completely about other ratios as well. So one ratio is sufficient to define that angle.
Sir, I can solve it.
Okay, no, I am not asking you to solve because it's very easy thing. You all can do it, right? So if you know sine A, you can find cos A, you can find tan A, you can find cot, sec, cosec, everything, isn't it? Right?
Yes, sir.
Okay. So if I ask you to compute the values of sine square 1 degree, 1 degree, how do I insert degree? Plus sine square 2 degrees up to sine square 90 degrees. Can someone help me find the value? Sine square 2 degrees plus dot sine square 90 degrees. Or maybe I should put 0 as well, because we always consider 0 as one of the angles. So let me add 0. How much is 0? So you have a few minutes to try it. If someone gets a answer, they can let me know. No one yet? Anyone able to
Oh, sir,
make?
I got it, sir.
Okay, great. So Shihari got it. Others are able to make any progress in any direction?
Yeah, I'm done.
So that is Manan, right?
Yes.
Okay, very good. How about Shaurya and Jainil?
Sir, I am not able.
I'm still solving.
Solving. Okay. So you have made a steps in some direction?
Yes.
Okay. Okay. Fine. Generally, you are not able to make any progress.
No, sir. I'm trying. But,
Hmm. Okay.
sir, maybe since this is an, can we call this arithmetic progression?
No, we cannot. Okay. The reason is we are not dealing with numbers directly. We are dealing with uh, sine and cosine of some angles. Okay, and they are not in arithmetic progression. Okay, and before we end this class, I'll try to uh, also take the graph page and show how these values change. Okay, because it's very important to have in mind how these functions change, how these functions values change. Okay, so we know the values of some numbers. We know sine is increasing. We know cos is increasing from 0 to 90 degrees. We know cos decreases from 90 to 0 degrees. But how exactly is this a straight line relationship? Is increasing linearly or non-linearly? So we'll have that before we end this session. Okay, so let me. Okay, Shaurya, are you still able to make some progress?
No.
Okay, no, fine. So maybe I'll ask Manan to help me solve this. Yes, Manan. How did you solve it?
Yes. So what we can do is we write sine square 1 as sine square 90. Oh, yeah, we write sine square 1 as sine square 90 minus 1.
Sine square 1 is equal to sine square 90 minus 1.
Yeah, sine square of 90 minus 1, which will be cos square 1, which will be cos square 89.
Is how you write it? Is it right? What I've written?
90 minus 89, sorry, 90 minus 89.
89. Okay, and then
So that will be cos square 89.
mm, no. If you are writing in this way, you cannot write cos square 99. How will this become cos square 89?
Because sine 90 minus theta is cos theta, right? So sine square 90 minus 89 becomes cos square 90 minus 89.
Okay, great, great. Yes, correct. So because sine uh, of 90 minus some angle is equal to cos of the same angle. Everyone knew this thing, right? Anyone here who was not aware of this? Okay, so this is cos square 89, right?
Yes,
Okay, fine.
and we do the same thing for all angles from 1 to 44.
Okay, and repeat it for all angles from maybe 0 to 44.
0 to 44.
So what he has done is he has converted the sine square 90 degrees into cos square 90 degrees. Sine square 0 degrees into cos square 90 degrees. Is this relationship known to you, Shaurya?
Yeah,
Yes, Janil. Okay with you?
yes, sir.
Shaurya, how about you? Hello.
Hello?
यस सो ये समझ में आया क्या ये क्या हुआ
No.
डू अग्री विथ दिस
Yes.
दिस ओके
Yes.
इफ दिस ओके व्हाई नॉट दिस देन हम 1 को लिख सकते हैं 1 डिग्री को लिख सकते हैं 90 डिग्रीज माइनस 89 डिग्रीज सो साइन 90 minus 89 becomes cos 89 and square of sin 90 minus 89 becomes square of cos 89,
Okay.
right?
Yes.
So from 0 to 44 degrees, I can replace everything by cos square 89 degrees. Or for me, it would be actually what I would do is I would go from 46 to 90 rather than from 0 to 44. The reason being, I always prefer smaller numbers than bigger numbers. They are much easier accommodated in my mind. माइंड तो छोटा है तो छोटे नंबर ज़्यादा अच्छे से आते हैं उसमें. Okay, so I would prefer to replace sin 90 degrees by cos 0 degrees, and then sin square 0 plus cos square 0, how much is that? 1. Similarly, sin square 1 plus cos square 1 will become again 1. So what we'll have ultimately, we'll have pairs of sin square 0 plus cos square 0 plus sin square 1 plus cos square 1 plus so on up to sin square 44 plus cos square 44 and plus sin square 45. This will be alone, correct? Rest all will become pairs, isn't it? Everyone agrees?
Yes, sir.
Yes, sir.
Okay. So now how many ones will be there? Srihari, how many ones will be there? Because this is 1, this is 1, this is also 1. So how many ones are here?
So there will be 45, sir.
45 1. That means 45.
Yeah.
Plus, what is sin square 45 degrees?
Sir?
What is sin square 45 degrees?
0.5, sir.
0.5. Okay, so 45 1 by 2. That's the answer. Okay. So that is one kind of problem. You can now, so whenever you see a sin square value and a cos square with the same value, you can easily combine them to make 1. Or if it can be converted into cos square, the same value, just like in this case, you can combine them into 1. Okay. The other kind of problems you will find is like you are given so P sin A and y is equal to Q cos A. Problem is find a relation between x and y.
Sir, here P multiplied by sin A
Yes,
or
P multiplied by sin A. So when we say P sin A, that means P multiplied by sin A and Q multiplied by cos A. So Manan,
Yes.
do you know how do we solve this?
Yes, I think I know how to do this.
Okay, great. How about Srihari? Do you know?
So I have a basic idea, sir.
Okay, you have basic idea. Okay. So what you ask to find is some relation in x and y. That means in you need to form an equation with x and y. Can you form an equation in x and y using these two equations. Shaurya, can you think of something?
Not yet.
See, most of the times these relations are already kind of, you already know. If we do a sine square of a plus cos square of a, how much it is? How much is that? Sine square theta plus cos square theta? No one answering. Janil, what is the value of sine square plus cos square a?
Sir, am I audible?
Yes,
Hello.
now you're audible.
Sir, I was not able to hear you before. I heard the question. Sine square a plus cos square a is equal to 1.
Equal to 1. You already know this.
Yes, sir.
So let's put in the value of sine a from the first equation. Isn't it? So this is x square on p square plus y square upon q square is equal to 1. If you know x and y are written in this way, this means the same thing. This is the relationship between x and y. X square by p square plus y square by q square equal to 1.
Sir, we can't simplify anymore, right?
We can simplify anymore if you want. Let's say what I can do is I can say x, or let's make this uh, keep this on the left hand side and equal to 1 minus this much, and then you can say y square is equal to q square times this thing. So y is equal to how much? Q times square root of this, right? Okay. So we can leave it either at this, or we can simplify y in terms of x. Both are this one same thing. And this is actually a representation for something in geometry, which you'll learn sometime later. I'll not show this to you right now. Okay, so I said before we end this session, I would like you to understand a little more on the sine and cosine, how the values are changing. So we'll go to desmos.com. And we are going to plot sine of x. How many of you expected this kind of a graph? Manan?
Right, sir.
You knew about this?
Yes, I've studied about it. So yes.
Okay, very good. Srihari, you too?
Yes, sir.
Okay, so since both of you have studied, I think Shor and Jain have not. I'll ask you both, both uh, Manan and Srihari, what is significance of this point? 1 point, it's just after 1.5, right? What is this value? Why it is maximum here? Srihari and Manan, this question is for you.
Because since the when you plot the graph for sin x on the graph, you take you take it into account as radians. So 90 degrees is pi by 2 radians, which is just after 1.5.
Okay, good.
And since its value is 1, so that's where its maximum value is.
Okay, great. So yes, that's the right answer. Whenever we use any angle without mentioning the degrees, okay, it means the angle is in radians and not in degrees. So unless I say degrees explicitly, so if I say sine 15, that would mean sine 15 radians. So if I want to say degrees, I need to say sine 15 degrees. Okay, Janil, Shaurya?
Sir, what is radiant?
Oh, you don't remember the radians and degrees? Okay. Uh,
Sir, degrees are, sir, radiance, it was mentioned in the class sometimes, but I don't remember
okay,
properly.
there are two ways to measure the angle. Actually, three, but two are primarily used. One is in degrees, another one is radians. So, radian is the angle. So, let me kind of do you know how to define angle? If you have a triangle, or sorry, if you have a circle, can you draw a circle? Insert shape circle. Okay, so how much degrees they create on this center?
Sir, 360 for the circle.
360 for a circle. If I cut a small portion of this, so let's say I take a line and cut this. Okay, so it is cut from this point to this point, right?
Yes, sir.
So uh, how much degrees or how much radians, whatever you decide, if this is my center, will it subtend on the center? Any idea? So angle subtended by an arc on the center is how much?
90 degree?
You mean to say no matter where this line cuts, this is always going to subtend 90 degrees?
Yes, sir.
That means if I create a line like this, it cuts the circle in two semicircles, right? What will be the angle subtended by one semicircle on the center? 90 degrees?
90 degree.
So you said just 90 degrees.
No, sir, you said for centimeter, for semicircle.
For semicircle is 180, you know now. What if it's not semicircle? It's already 4 o'clock. So maybe I'll stop because there is another session right now, right?
Yes, sir.
Yes, sir.
Okay, so we'll continue it in the next session. It's not ending. It will continue because we need to cover a few things more. Thank you.
Thank you, sir.
Bye.
Thank you, sir.
Thank you, sir.